And here we are. Hello, everyone. Nice to have you all with us today. My name is Jacopo, and I'm super happy, from one of the organizers of the Kubernetes and Cloud Native Milano meetup. I am super excited to have Luca and Alvaro with us today, right from SysDig. They are going to talk to us about best practices, security and general best practices, around writing Docker files and containerizing your applications. So Alvaro, Luca, not sure, do you want to very quickly introduce yourself, and then we can just go straight off to the presentation, to the talk.
Thank you, Jacopo. Yes, so I'll start by introducing myself. I'm Luca, and I'm a software engineer at SysDig. I've been working with container technologies, and I'm very passionate about security, and I'm very happy to have the chance to share a bit of knowledge and information with everyone. And I'll let Alvaro introduce himself as well.
Yes, I am Alvaro, also software engineer from SysDig, also a broad experience, especially in DevOps, CI/CD, and now in security, also working with containers and with Luca. And I hope you enjoy the presentation today very much.
Okay, awesome. So let's jump to the presentation. Before we start, I would like to, invite all the viewers to just write down, in case you have questions or in case you want to, write anything, just feel free to leave a comment. I will just gather all the comments, and then we can have a nice Q&A session at the end of the talk. So yeah, guys, I just leave you to your talk. Okay, see you later.
Thank you again, Jacopo. And as I mentioned, I'm Luca. I want to also mention that I was born and raised in Milan, and so it's great to be part of the Milan meetup. So let's start by just saying what SysDig is, just in case you aren't familiar. SysDig essentially is a company based on open source software. So if you recall, we've got a SysDig open source application, which I really like and I find handy. I will show later why, and also Falco, which is the CNCF basic security tool that works with Kubernetes and all this kind of technology. We are built on open source, so everyone is welcome to contribute, and that's also why I got interested in the company in the first place. Anyways, what do we have in store for you today? So for today, we're going to first try and understand why we actually care about container security and Dockerfile best practices. And then we're going to go through the basics of the container security model that we've been using for a while. And then we're going to use this knowledge about security to write a bit better Docker files, and then add up to many more things that we may use in our applications. So first question that we can think about is, why do we actually care about what we're writing in our Docker files? So these best practices and these things that we're going to discuss are mostly related to security and ease of deployment of our application. It's very tempting to think that security is not actually our problem, especially if you're engineers. We might have a security team, we have a DevOps team, and essentially those teams, we may think that those teams are the ones that that actually need to make sure that our applications are secure and they can be deployed easily and everything goes smoothly. However, what I'd argue is that rather than thinking like this, we may just put a bit more effort into our designs and our Docker files in such a way that our DevOps and security teams will have a much easier life. And also, if even if we're engineers, if we are happy with our DevOps and our DevOps like us, we are going to have a much better life at work, rather than if we go against what they like and they turn into VOFH, if someone remembers what those are. So let's start by thinking a bit about the container security model. So this is basically what we have been using for many years. This security model has been in place probably since maybe earlier than 2014, when first versions of Dockers were introduced. So this is nothing new, but some people may not be familiar. For some other people might need a refresher because they saw it before. And I'd like to go a tiny bit deeper than usual when looking at this stuff. So, of course, since we're talking about containers, I do need to share this slide, and I would like to use this as what I think containers are about. So I believe that, and what I believe that the container use and the container design was about. Containers are not really about containment, so they haven't been, I think, really designed with the idea of being a Fort Knox, something bulletproof, where nothing gets in and nothing goes out. Containers are awesome for me and for many people because they allow things to be shipped very easily, to be transported very easily, to be transmitted over the internet, and to be installed and removed. So that's the power, what I believe it's the power of containers and why we use them so much. If you think about these things, those are containers too. I mean, this is they don't really have much security, so this thing looks dangerous. Someone could blow it up pretty easily if they want to, but we still call them containers and we still use them as container because they are so easy to transport. You can carry this boat on trains, trucks, larger boats, because they are standard format and they can be moved around with something that people know how to use. So if we are back to our software containers, I would like to think about the first time I ran a container. Someone just told me to run this command. The first thing I got was a permission denied error. I had no idea. I thought, oh, come on, do I have to sudo really? And then I ran the thing and I got a root prompt at the end. So I started thinking, what is this? Is that root, virtual root, some kind of root? Variations. I only had experience with virtual machines before, and we know that containers are essentially processes running on a system. So maybe what was that? Of course, I immediately believed that something magic was going on without thinking, because I did have my application to develop. But in time, I thought a bit deeper about this. So, well, my assumptions were that my container cannot just wipe down my entire host, and the file system is limited to what the image provides, because I mean there is an image that they send, and of course my host information was somehow siloed or constrained and separated from what the container could see. I was kind of right, but let's just think about the technologies that allow this to happen. When I tried at some point to see, well, I mean, there's a user, so let's take a look and see which user is actually running that container. I could easily see that there is a process in my container that I ran with Docker, and the UID of this process is 0. So yeah, this is actually root. It's not like a virtual machine or anything where the thing is separated. There is a root process on my machine. So what's the magic here? We might have heard, I think, about some of these names, and each and every one of them is a massive rabbit hole. So let's try and give an overview and see how these work in making our containers. So first of all, these are basically Linux kernel technologies that have been put together to have Linux containers that we use today. We might have a pivoted environment, so basically our root directory of our process is somewhere else. That's not the root directory of the entire system. And then there's this thing called namespace, which have been introduced in 2002. That was almost 20 years ago when I mean, Italy switched from lira to euro. That's nothing new, really. And that's with the first namespace. And then we've got C groups that allow us to limit resources. And then maybe not everyone is familiar with what capabilities are, or SecComp, AppArmor, or SE-Linux. They have been around for really quite a while. But let's try and see what these namespaces are and how they work. So a namespace is essentially a way for the Linux kernel to tell a process that they should not see a whole global resource, but they should have an isolated resource. It appears to the process that they have an isolated resource that's part of the global one that exists in the system. A very basic example of this is the PID namespace. If you run a container, you will see that the process thinks that they have PID1. We all know that PID1 is the init process, the process that creates all others in a Unix system, might be managed by systemd in mother system, but it's definitely not our application binary, our Python interpreter, or whatever that we are using in our container. And this is allowed by the PID namespace. We've got network namespaces for network isolation, mount that allow us to do this thing like docker-b and add directories there that appear as if they're external devices. And we've got IPC, of course, for shared queues and shared memory, and we've got UTS for the name. And if we look carefully on a basic container, this is essentially a view in the Dockerfile system of an uncontained process. That's actually my init via systemd. And this is a container. We can just query the kernel because the Linux kernel speaks to us via the file system. And we can see that with no further option, like the default has the same user namespace that our system has, which reinforces the thing that reinforces the idea that actually we are running as root. So what else is there to prevent this thing from running wild? What is there is a thing called capabilities. So if you see these hieroglyphs on the left, essentially this is a script that would allow you, if a container was configured via C groups and namespaces in the same way that I have discussed before, this would allow you to escape from the container very easily. So basically, you can access all the rest of the file system or rest of resources without the magic of namespaces stopping you. Why is that? That's mostly because root is too powerful. Root is really the god of the machine. So what the kernel, the Linux kernel, allows you to do is essentially split root's superpowers into a series of discrete capabilities. So in this case, as you can see, my real root on the machine has all the capabilities, but there's at least 38 to choose from, while the contained one with Docker's default only has 14. And this is what allows us, allows us some degree of security. But we need to know that this is there, and it may not be perfect, but bugs can be found, but this allows us to have a container that doesn't just escape instantly. There's more, of course. You can specify which capabilities to drop if you want. And then there's SecComp, if you know it, allows you to do a bunch of things. But one very important one is for a process to tell which system calls it's allowed to run from the point where it calls the system call, the specified system call onwards. AppArmor and SE-Linux are layers on top that are not available on all kernels and all distributions. But for example, if you're using OpenShift or a Red Hat-based distribution, you're going to have SE-Linux, which is essentially a mandatory access control built on top of the Linux file system. This has been around for really quite a while. If you remember, this has been built by Red Hat and the NSA for this specific file system need. But for SecComp, AppArmor, and SE-Linux, especially the last two, I don't think you can assume that those exist in your cluster or in your deployment if you're using Kubernetes, and you have to check. Because for the others, I think they are default almost everywhere, but sometimes you do need to configure them. So I wanted to show you an example of, I wanted to dive a little bit deeper and show how this magic actually happens in a container. To do this, I'm going to use Sysdig, which is the open source application that has been around since 2013 or 14, I believe. So it's been around for a while. We can, if you've never used it and you're not familiar, think of it like TCP dump, but for system calls. So we can run it with this one-liner. We can run the system, we can ask it to record the system call that it's reading via its own kernel module or get probe. And then I just ran a container. And I took trace and I took note of which PID that was running under by just asking Docker. So then I can replay this SCAP file. And if you've never seen it, again, it's like a pickup file and it's not an accident. And I can actually ask, and I can filter the system call that happened just to see how this process is created. If you're familiar with Unix and how this works, you will be familiar with Unix, Linux systems that do a fork and exec. This is clone, which is a fork with more options and a bit fancier, but the idea is the same. So a process is created and is cloned via this clone. And at some point, the image of this process in memory is replaced by my bin entry point, which is the file that I set up as entry point. However, Sysdig is nice enough to show me that when this clone is happening, the virtual PID of the process is still 1, so there's a namespace already in effect. So how is the namespace created? We can dig a little bit deeper here and notice that everything starts with this binary called runc, which is executed via the Docker daemon, of course, through containerized. And actually, this runc says create, has a create verb, and it sends a file, which is a JSON file in this case that is sometimes called container configuration object, which tells all about what namespace it should have, what security, something about the file system, essentially everything that you need to run the container. And this application, runc, will eventually become our containerized process. And so where's the namespace coming from? Well, if we look at runc, we'll see that it spawns a parent and a child. And at some point, we will find this system call called unshare. Unshare essentially means please put myself into a new namespace. And it's actually asking for IPC, network, mount, PID, and UTS namespaces. Note that it doesn't ask for user namespaces because we didn't configure one, and by default, as we saw, it doesn't really do that. And why does it actually need to call a clone afterwards? Well, it does need to do it because from the manual, it says that if you want a new PID namespace, that will be effective only with your children, your child processes. So it's going to immediately clone and let the runc do its more initializing and the container magic to happen. So I hope that you found this little trip within runc and the container world cool. If you liked it, of course, you can go as deep as you'd like. Runc, Docker, they're all open source, and there's other binaries that run containers such as crun and maybe more. What can we learn from all this? Well, we can learn a bunch of things, but if we think about our applications, when we are going to deploy our applications, we probably want to use the principle of least privilege to have the least possible privilege that our application can run. Of course, we have heard already in best practices that there is you can actually decide to run the container as a non-root user, even without user namespaces. You can just run it as non-root. And by default, you get root with less capabilities. Usually, you find written that you should never use privileged. However, I would like to argue with this one because I already used the privileged in this presentation, and so if I said never to do it, I would be lying. So I ran Sysdig with privileged. Privileged disables all capabilities, seccomp, parmor, SELinux, but can keep the namespaces if you want. I needed privileged because I needed the Sysdig to have the full permission to access my host, because you do need full permissions in order to read all the system calls that happen in the host. There's no way around it. But if you think about it, so why did I use a container? Because I didn't really want to mess with the dependencies that Sysdig may have, or to download the repositories, binaries, and so forth. I just wanted my privileged process to run in a container and shut it down when I'm done with it. So that's a use for privileged. Root with less capabilities is the default. So what's the difference with the no-root user? I mean, if we've got all these security features, why would we want to change the user? Well, for starters, still the root has permissions in the file system. So if I were to mount my whole root directory in a container that runs as root, even if not privileged, it would be able to wipe everything down, no problem. And about the rest, of course, it's going to have a bunch of capabilities that usual users don't have. And so, which means that if a bug is found in the Linux kernel that allows some of these capabilities to have a bit more power than they should, then I would be exposed. So let's try to do so. Of course, since the default is root, we can see that a lot of containers run as root, which is of course life. There's also many more things apart from the user that you can use to escape from a container or to do lateral movement. And we've got an article on that. It's a bit outside of the scope of this presentation, but you can take a look if you're interested. So ALVARO sent me an application, and it was with a default Dockerfile. So this only had, now we're talking about Dockerfiles, if you noticed. So we've got a basic from, copy, and an entry point, which means it's running as root. Let's try to remove some of the privileges here. So we've got root directories, root logs, everything is fine. We are going to put user 1000, and then it doesn't work, of course, because there is a permission denied issues. So how do we go around that? One thing that came to my mind instantly is saying, hey, well, I mean, we can just take the application directory and just make it owned by the specific user, so it will have all the powers to do this kind of stuff, whatever it likes in the app directory. There are more things that we can do, and also ALVARO later will talk to us about them. But actually, I would like to, if possible, to think a bit further. So the Unix basic file system permission usually works by having directories that are owned as root and binaries that are owned as root. In this case, for example, would this application work out of the box? It should basically, because the directory is now owned by app, and the user has a read and write permission to make it work. But since the directories are by default owned by root, can we go a step further? Yes, I think that if possible, we can just try and separate our binaries and static assets from the data that our app operates on. This way, we may find it easier to deploy and to actually make our application run, because you know that the application is not able to modify its own binaries, and you're sure that if you did something wrong, for example, having an application trying to update itself or to download itself while it's inside the container, which is not really something that you should do, because it does defeat the purpose of having an image out of which spawning your application, you will get an error in that case. Of course, you cannot do all of these things in all applications, but if you can, at least if I can, I will always try to do it because I think it can save me headaches going forward. So right now, I'm going to pass this to ALVARO, who is going to talk to us about many more best practices that we can use in our Docker files and when we talk about containerized deployments. Thank you.
Thank you, Luca. So I am ALVARO, and as you can see on this slide that Luca added, this is my dark past, AMSN. So it's a software, apparently you can still download it, but it will be useless because the servers were shut down. But let's go back to container security, which is a topic we were talking about. So basically, Luca was talking about choosing your application privileges wisely. He showed how to run a container as a standard user instead of root, and separating the binaries directory and the application directory. And another thing we can improve is what happens if, for example, I try to run this container as a different UID using this -u1001 parameter to Docker. What will happen now is the application will fail because the application is trying to write to the access log in the same folder which we just set permissions to user 1000. So this is not going to work because user 1001 won't be able to write to this folder. So the application will fail to start and work as expected. Okay, then what can we do? We can, for example, change the work dir to /tmp. TMP is a special folder. It has the sticky bit permission. So permissions are special, and anyone can write to /tmp and become the owner of the files it just created. So by setting the data or the application folder to /tmp, we can fix this problem, and we can make the container running as any UID. In this example, 1001. So if we check again inside the container, we can see that now the access log file is owned by user 1001, and the owner, well, the user running the process is, again, user 1001. Why does it make sense to allow running as any user? Well, it makes sense because, for example, some orchestrators or runtimes, like the OpenShift clusters, won't allow you to run, by default, won't allow you to run a specific user, but they force you to use a random UID for security reasons. You can override that, but it is the default behavior. And for example, being able to run as any user UID is also very useful for matching permissions. You can mount folders inside the container from the host or from persistent volumes, and it is usually easier to change the UID the container is running to match the external permissions instead of trying to match a folder that is shared among multiple containers, for example. Okay, let's move on, and now let's briefly talk about a different topic: reduce attack surface. What does this mean? Okay, the problem is if we are including unnecessary packages or exposing ports that you are not really using in your container, then the risk you are assuming is that your system is more exposed to attacks using these ports or exploiting vulnerabilities in these packages. And also you are using components you maybe don't need, and they are not under your control. So again, you might be including vulnerabilities or some ways to enter into your container and exploit them. So let's see how we reduce attack surface. And before that, let's briefly talk about how should we build applications that we put inside the container. One of the things you shouldn't do is build the application externally outside the container and then copy it into the container, even if it is just what we did in the previous examples. Why this is not a good idea? Well, basically because you are missing a great feature of containers, reproducibility. What is reproducibility? Well, you don't have control of what is in the outside world, outside your container. So that means that different developers can be using different compilers, different libraries, or dependency versions. So the binary that a developer builds outside the container and then copies inside the container might have a slightly different depending on who built the container. So this is not a good idea, building outside the container, because you are missing reproducibility. How can we get reproducible builds? Well, basically, I said containers have the nice feature of reproducibility. As long as you use the same container, everything you execute inside the same container will always produce the same result. So you could build, and you should build inside a container, but not like in this example. So don't build it directly inside the final container, which will be used to distribute your application. In this example, we are installing the Go compiler, the Go toolchain inside. We are copying the application source code into the container, and then we are building the application. Okay, reproducibility is good, but we are including tools that you are not going to use and you don't need it, and they are increasing the container size. And also in this case, you are including the source code of your application inside the container, which probably you don't want to do. And even if you remove the SRC, the source code folder later, it will be still accessible. We will see later with an example. And also there is another wrong thing. I talked about reproducibility in here, but this isn't reproducible at all. Didn't you notice why? Well, I said this is reproducible, but we aren't pinning any version. So this Alpine will take the latest available version from Alpine. This APK at Go will install the latest package from Go. So in a week later, we can run this Dockerfile again, and probably we are getting a different version from Alpine, from the compiler, etc. So this is not real reproducibility. So what's a better approach to get reproducibility? Well, basically, you build in one builder container, and then you copy the resulting artifacts to another container, the final container used for distribution. You could use 2 different Docker files, but you can also use the multi-stage builds feature that Docker offers. Using the multi-stage builds, you can use a single Docker file where you define a first stage, the builder stage. In this case, we use the Golang container with a specific version. Here, we copy the source code into the container. We run the compiler and get the binary, and then we define the final stage, which will be built on top of Alpine, smaller image, and we only copy from the builder stage, the previous stage, the resulting binary. No need to copy the source code or all the other things. So basically, this is a very exaggerated example, but in this comparison, we are listing the images. The first one is the one without using multi-stage, building everything inside the container. And the second one is the final stage of the multi-stage version. So you can see we have reduced from more than 400 megabytes to just around 8 megabytes. As I said, probably this is not a real example because we are building just a hello world application. A real application might include other dependencies and packages, and the number of megabytes might grow. But I guess you get the idea. And also, I show you a Go example, but this can be applied to many other languages. If you search, if you Google or search in the internet for multi-stage builds, whatever language you are using or prefer, you will find a lot of examples. In here, I'm quickly showing, I'm not an expert on JavaScript and TypeScript, but basically this example I found over there is using the initial stage to compile the TypeScript files into the final JSON form, and then it is using a final stage based on also Node, but it is only copying the package JSON, only installing the production packages, dependencies, not the dev dependencies, and then copying the lib files, which is the compiled JavaScript files, into the final container. No need to include the original TypeScript files. As I said, please find examples for the languages you are using on the internet. Okay, another thing to try to avoid is try to avoid using big generic distributions as your base image where you will distribute your application if you don't really need it. For example, here I have run the Sysdig inline scanner. It is an application that will scan a container image and detect vulnerabilities, bad practices, etc. I am running it on the Ubuntu latest image, and it found I have cut the output just to highlight some findings. And in red, you can see that there are some vulnerabilities in here, in DPKG, GCC5. There are also some files with setuid, which is considered a bad practice, etc. So this makes me wonder, will you need in your final image where you distribute your application the GCC5 compiler or the sysv compatibility scripts or DPKG package manager or even the bash shell? Indeed, in this image, there are more than 100 vulnerabilities that have been detected by the Sysdig inline scanner, and most likely you don't need most or many of these packages for your application to run. So we will talk about some alternatives soon. And what about using official images? For example, using the official Node Docker image, official Apache, official WordPress, etc. Well, the official images normally come from a verified and trusted source, but they are usually focused on providing a nice experience for that specific application. So it is like an image to showcase Apache or Node or whatever. So they in general, try to cover more generic use cases, and they might include additional libraries or additional tools and helpers to focus on showing or using the features of that product. And probably you don't need that. We will see alternatives again soon. The other one is obvious, but please try to avoid, don't use images that are very old, outdated images, because new vulnerabilities are discovered all the time, continuously. So if you use an outdated image, there is a high probability that there are vulnerabilities that can be exploited. So try to stick to latest versions, try to stick to images that provide frequent updates and so on. And also, no need to go mad and always use the latest bleeding edge version, because that might introduce breaking changes and it is hard to follow the pace of development. But try to stick to long-term support versions, etc., which provide frequent updates, minor versions, fixing security issues, and so on, without the need to keep a constant track of the breaking changes that you might need to adapt your applications on. Okay, let me talk about another common cases that you are searching for a base image for some features to deploy your application, and you found that this guy, the John Doe hacker, has published an image in Docker Hub which fits your application requirements very nicely. Why shouldn't you just blindly take this image and use it? Well, there is a lot of reasons. For this image, you are inheriting all the problems and vulnerabilities that the image that John Doe hacker created already contains. Also, you probably don't know who builds and publishes this image. You don't know if that image is going to be updated regularly, including fixes for security issues and so on. Also, you don't know how it is built. We don't even are sure if the Dockerfile that you found in the GitHub repository for this image, even if there is a Dockerfile, it might be just the image in the Docker Hub, but even if you have a Dockerfile, you cannot be 100% sure that the published image in the registry is built from this Dockerfile. John Doe hacker could have built a different image, introducing some malware or something, and you might be hacked or vulnerable by using that image. So I talked about a lot of don'ts, but then what should I do? Well, basically some generic, also this is not the rules you should follow 100%. Try to be wise and think about what you are doing. But basically, these are some tips. Prefer verified and official images from trusted repositories, from trusted providers, over untrusted, I don't know, sources like this John Doe hacker we just found. Also, please don't just take the first image you find, which might not be optimized. So check if there are better versions, optimized versions, better suited for production. For example, Bitnami offers some images like for Node and many other tools that are customized versions built on top of a mini dev distribution, which is smaller than Ubuntu or Debian. Also, they build frequently, update the latest bug fixes and security issues and so on. They sign the images with Docker Content Trust, and they also provide a page where you can track the known vulnerabilities for those images. So, in general, also some more tips. Try to be minimal. In general, well, for example, Alpine is a common choice. You can find many official images that provide an Alpine version, which is a very small Linux distribution. Ideally, you could build your image from scratch, from a blank empty container, but this is usually impossible due to binaries depending on some basic system libraries or configuration files. Also, there is a project, the Distroless project from Google Container Tools, which is a common choice. They offer very slim, stripped-down images which contain everything but the essential libraries like glibc, libssl, etc. Even there is a slimmer static Debian 10 versions which can work for statically compiled applications like Go that don't require libc. Also, another good question is, should I include a shell or shouldn't I include a shell in my container? Well, including a shell obviously makes it easier to debug, but at the same time, it is easier to exploit if you can shell into a container and execute commands in there. There are alternatives, like, for example, if you need to debug, you can use a sidecar container with a shared volume and connect to the main container, etc. Or you can, for example, build debug versus production versions of your container and include the shell in the debug version, but not in the production version. So again, be minimal. Could you use a ship like this to just cross a small river? For that purpose, you can use a small boat like this and save a lot of trouble. So, more tips. What happens if I find a custom image like this John Doe hacker that works for me, that fits very nicely? Should I use it blindly? It is better if instead you check for the image source, you check the Dockerfile, and you take that as an example, but instead you build your own base image using those Dockerfiles. It is also interesting to take track of the upstream changes. So in case the author of this image makes improvements, you also can take advantage of them and merge them into your Dockerfile. But just don't rely on untrusted published image. Better take the Dockerfile, the source, and build your own image. Also, In either case, even if you use provided images by official sources or you are building your own custom versions, please, this is very important, define a version strategy. What is this? Well, let's face it, later or sooner or later, you will have to update your images. So try to stick to stable or long-term support versions so you are sure that you will be receiving fixes for that image for a while. Also, try to rebuild your application, your container on top of that base image periodically or whenever new fixes are applied to the new image to get the latest upgrades and the latest fixes. Also, not only the distribution, the base distribution packages, but also think about language-specific packages. For example, NPM, GoMod, etc. offer ways to specify version ranges for your dependencies, so you can keep using latest security updates, but don't go to with the breaking major version changes. And also, it is very important, plan in advance and be ready to drop all versions. Migrate before the base versions or the libraries you depend on reach the end of life and they stop receiving updates. For example, MySQL 5 is not supported and a new vulnerability has been discovered recently. Okay, this is an example. So if you were using MySQL 5 and tomorrow a new critical vulnerability is discovered, it might take a long time to migrate to jump to a new version like MySQL 10 or MariaDB or whatever and test everything with the new version. So don't wait until MySQL reaches end of its life for that version and plan the upgrade in advance. So in summary, to try to prevent problems related to attack surface, keep your images minimal, include only required stuff, carefully choose the image that best fits your use case, use trusted verified images, a stable, well-maintained version, frequent updates, update and rebuild often, and have a versioning strategy and plan in advance. Now, let's talk about credentials and confidentiality or leaking data. What is this about? Okay, the problem with leaking credentials in your images or confidential information is that attackers can use these leaked credentials to access your system, or simply you might be exposing confidential sensitive information from your company and you are getting into trouble. Let's see an example of what shouldn't ever be done. Please never ever include hard-coded credentials in your Dockerfile, or please don't add credential file or environment variables in the Dockerfile. What happens if I create a Dockerfile like this where I set an environment variable with an API token? This is a fake one, don't try to use it. And then I copy an AWS credential file into my home directory. Okay, it is as easy as inspecting the container, running docker inspect, to just get the value of the environment variable from the config. So that value is not safe. And getting the content of a file is also super easy. You can just run a cat command and cut the file, and you get the credentials. Okay, you might say, but I can copy these credentials in here because I need it in a later step. For example, I'm running something that needs to create a bucket in AWS, so I need the credentials in then. And then later I will remove the file. Okay, this won't work. It is not that easy. It is a bit trickier because if you try to cut the file doesn't exist in the final image. But you can use a tool like, for example, Scopio, that is capable of copying an image and copying it to a different format. This is an OCI format, a folder with one file per each layer. So you can check the index file. The index file will tell you the guest for the configuration file. You can check the configuration file. And if you check the configuration file, you can see that there is one layer per each command you execute in your Dockerfile. And you can, for example, take the guest of the layer before the last one, this one, and then I can just extract the tar file that contains that layer that I just copied to this OCI folder. And then you can see that there is a credentials file in here, and you can just cut the contents of that file. So again, we are exposing. So please don't forget the layered nature of images. Containers are composed of a set of layers, and each command creates a new layer. This is great for distribution, for sharing, reusing common layers from base containers. But at the same time, as we just saw in this example, it means that if you remove a file, it is still accessible and it is still taking space And it can be accessed by extracting making some conversions and extracting the tar files and so on. So removing a file just means that it is marked as erased and it is not available in the final composition. And this, by the way, brings up another couple of optimization tips. First, it is a good idea to combine, if possible, multiple run commands into a single one to reduce the number of layers. And second, more stable layers or commands creating layers less likely to change should be placed first, as they are easier to catch and they will speed up the build process. Let's see with an example. So in here, we are running multiple commands. We are copying a source code. We are installing wget and node.js. We're downloading a file, extracting it, and then we are doing some cleanup. We remove the downloaded file, and we remove the wget package. Okay, so an optimization here is we can chain the commands using the double ampersand operator. So if a command fails, it will interrupt the execution of the rest of them. Basically, we are doing the same, but we are running one single command. So the final result of this command won't have wget or won't include the contents of the downloaded file because we have removed them. We can see with a quick Docker images command that there is a small size difference, a couple of megabytes, which is just the wget and the downloaded file not being present in the second version, the version where we join all the commands into one, because the layer is the result of the command, as I said. So wget and the file are removed, and there is no trace of them in the final image. However, with the multiple layers versions, wget and the downloaded file could still be accessible in intermediate layers. So again, if we inspect the unoptimized version, there is one layer for each run command. And if we compare with the optimized version, we can see that only one single layer was created, combining all the instructions, all the same instructions, because we executed a single run command, so only one layer was created. Regarding layer ordering, how to optimize to take advantage of the cache, you can see in here we are installing some packages, and then we are copying the application JavaScript files. What is likely to change? The packages and the commands we execute in here, or the JavaScript source code of our application? Probably the application will change more often because we are developing the application and testing new versions. So it makes sense to put the copy source star at the end instead of at the beginning. This way, this run command will be cached, and every time you do a Docker build, this will be executed from the cache. In fact, nothing will be executed. Docker will just reuse the same layer, and this will be quite fast. And only the copy, the new files, in case something changed, will be executed. If you put the copy at the beginning, any change you made in any file inside the source folder will invalidate the cache. So Docker will need to execute this, and then this command won't be possible to run it from the cache. It will be need to execute it again. Okay, another typical leakage point is the build context. And what is the build context? This dot at the end of the Docker build command is the build context folder. So all files inside this folder are sent to the Docker daemon. So be careful. You can send confidential files, source code, configuration files, backups, log files, temporary files, etc., because all copy and add commands work from the build context. Everything that was in this folder is sent to the Docker daemon, and then copy and add operate from there. In this example, we do a Docker build, we specify dot as the context folder, and this copy command would copy the Docker file itself, which is in the current folder, inside the /myapp folder. And probably that is something you didn't intend to do. So good practices regarding the build context include using a clean build context. For example, you can use a clean folder which contains only the required files for the image building process, and also include a Docker ignore file to explicitly tell Docker which file should ignore. Also, it is also interesting, but prefer using copy over add. Also, try to avoid wildcards if they are not necessary. But why copy over add? Well, copy is more explicit. Add can do many other things. It can, for example, download a file from a URL and extract it, or it can directly extract a tar file. But in case you don't need that functionality, please use copy instead of add. And now a quick discussion about linting and scanning. Why linting and scanning? Well, because humans like me have the bad habit of making mistakes, but fortunately there are tools. This is just an example, the Haskell Dockerfile linter or Huddle for friends, that can detect the bad practices in your Dockerfile. Huddle can even expose issues in the shell commands you run in the run command. And for example, the sysdig image scanner is also, apart from detecting vulnerabilities, can also detect bad practices. Like in this example, you can see a container running as root or exposed port for the SSH, etc. So try to use this kind of tools to detect these bad practices or problems. And as usual, automation is better than manual, so consider incorporating this kind of tools in your CI pipelines. And so far, I have focused in writing the Dockerfile itself. This usually happens in the developer realm. So we could say so far we have learned about making the coffee, but now it is time to enjoy our cup of coffee. So let's talk about other stages in the container lifecycle. For example, regarding image scanning, what is image scanning? Image scanning is running a tool which detects known vulnerabilities or bad practices in your image. It is preferred the earlier the scan is performed, the better. So you detect the vulnerabilities and the bad practices earlier and you can fix them, but it can be performed at different stages of the container lifecycle. And where should the image be scanned? Well, it depends. Again, as I said, earlier is better, but it is not always possible. For example, a developer can scan the image locally before pushing the image to, not the image, but usually what happens is that the developer pushes a Dockerfile to a code repository that triggers a CI/CD pipeline. Okay, then a developer can run the scan locally, but also it could bypass the scanning intentionally or just forget and push the Dockerfile to the code repository. This could trigger the CI/CD pipeline. So scanning the CI/CD pipeline right after building the image and before pushing the final image to a container registry will prevent pushing unscanned or vulnerable images into the Docker registry. Then, why does it make sense to trigger scanning using a webhook or similar? Many container registries offer that option when we push a new image to the registry. Well, you cannot guarantee that every image uploaded to a registry has gone through the CI/CD pipeline and has been scanned. Anyone might just push, if it has the corresponding credentials or permissions, could push an image to the registry. Okay, then you can scan an image right before deploying the image and running it, for example, in a Kubernetes cluster, using a Kubernetes admission controller. This way, you could prevent deployment of vulnerable images from other registries, for example, public registries where you don't have control of the scanning. Again, admission control is not always available, and also it can be quite disruptive if you stop some critical images from running. So sometimes it is just good enough to make sure that all the images you have running in your cluster are scanned and you get a nice report of all the known vulnerabilities in order to take corrective action of the known vulnerabilities as soon as possible. And then good practices and security stay way beyond the image building itself. Luca, for example, talked about container security in runtime, how excessive privileges can be exploited, but there are even more things to consider. So, for example, you cannot just create a container, execute it or deploy it, and just leave it running in the wild and forget about it. Why? Because new vulnerabilities are discovered daily. So there is a time frame since the vulnerability is discovered until you take corrective action and deploy a new fixed image where your image is vulnerable and could be exploited. So remember, update your images often, have a versioning strategy to make it possible to keep these time frames since the vulnerability is discovered until you deploy a new image. Try to keep this time frame as small as possible. But also, detecting issues for runtime images that are running, is also quite important. For example, you should reevaluate the already scanned images periodically in order to detect new vulnerabilities, because vulnerabilities are discovered every day. So it's possible that there is a new vulnerability applying to an already running image, an image that you already scanned. So reevaluate and get alerts in case new vulnerabilities apply for your images. Also, Tools like Falco or Sysdig can help with runtime threat detection. In this case, these tools can help you detect suspicious activity, strange systems call or activities, and again alert you so you can take corrective action. And finally, respond to suspicious activity. For example, you can stop or pause the container and then do some forensics and try to find what happened in there. Okay, and it might sound like a low budget movie, but mutant tags are a real issue. What is this mutant tags about? Well, the image pointed by latest tag today might be a totally different image tomorrow because the tag latest or any tag can mutate. You can read more about this in our blog post, Attack of the Mutant Tags, or why tag mutability is a real security threat, and also available as a talk in Virtual React 2020. And finally, threats are present even before you build your first image. The Docker socket itself is a big privileged door into your host system, the host or the system where the Docker daemon is running. So basically, having access to the Docker socket, it means that you can execute privileged commands in the host system. So make sure the permissions for /run, /var, /run, /dockersock are set correctly. That is the reason why Luca had to execute sudo for his first Docker test, right? And if the socket, especially if the socket is exposed via TCP over a network, make sure it is properly protected using a proxy, TLS, or whatever. About distribution of images, container images can be digitally signed using Docker Content Trust, Docker Notary, Harbor Notary, similar tools. You can use them and then instruct your runtime system to only allow trusted or signed images. And finally, even the finest piece of software can fail. Because of that, Docker and Kubernetes offer health checks or liveness proofs that can verify that the application or service is alive and running correctly. Please use them, especially for critical, long-running or persistent services, so they are automatically restarted in case or malfunction. So remember, we are from Sysdig, and we are looking for talents. We are hiring. In case you might be interested, please get in contact with us. And that was all for today. I hope you enjoyed. Thank you, Jacopo. Thank you, Luca. And now it is time for some question and answers.
Thank you, Alvaro. Thank you, Luca. Yes, so time for questions. Is there any question from anyone viewing the presentation? If so, please just feel free to write them into the comment section so that we can give you like a live answer.
Yeah, so
questions.
Comments are welcome because this is not like written in stone. Some of these tips are opinionated, at least by me, and some people disagree on some points. So it is interesting also to open a discussion in case you don't agree with some of them.
I have a comment in general. I liked a lot when we had this meetup in person where, at the end you could get aperitivo with everyone and drinks and stuff. Sadly, we cannot do this anymore. But maybe in the future, maybe Jacopo, if we'll be back, please let us know. And
I think there is a question.
Yes, so we have one question. Let me show it for everyone. So we have Mirko asking, can I get a Dockerfile from an untrusted image?
So I guess you mean, for example, if you find an image, this John Doe hacker published the Dockerfile in GitHub, you can get it. I mean, you can take it from GitHub, and the good thing, GitHub or whatever open source repository, and then you can examine it and check what that image is doing. And if you feel confident enough to use it, that is great. I don't know if that is the purpose of the question, or if the question is
maybe
the Dockerfile.
Maybe I thought the reverse. Like, if I got an untrusted image, can I work out what the Dockerfile was out of that one? Mm-hmm. So I think, well, the answer is kind of. You can get a part of it, because when Docker builds an image, or there are other tools as mentioned that can build an image, they do add a specific line for each diff IDs, that would be the things that at the end make the layers, which will tell you kind of sometimes the command that has been run. But for example, for files, you will not see what the Dockerfile was saying at the beginning. You will probably see copy and then a hash, because that's how the daemon registers it. But it's very, actually, if you want to do it, it's super easy. Just with Docker, you just do Docker, I think it's history. Yeah, Docker history. You put your image name, one that you've just downloaded, and if you have to add the parameter --no trunk, because by default you get a truncated output, and you can see what's recorded in the image for that specific Docker file. Thanks. Cool question, I think.
Yeah.
We have another question, this time from Ramiro. So have you tested some alternatives for building Docker images without actually using Docker, like Canico, for example?
Yes, Canico. I think Canico is a very common one, especially for Dockerless environments like Tekton and these CI/CDs. Also Builda, I think that's from Red Hat, and also Docker is moving to a new engine, BuildX, which is replacing the old Docker, and some of them have nice features like running unprivileged, even rootless for some very specific images. So yes, there are many other, but most of these practices probably apply are engine independent.
So they do actually apply regardless of the engine that you are going to.
Yeah, most of them.
Use.
Yes, I'm not sure. Maybe some of them are specifically tied to Docker, but most of them probably are generic enough to be applied regardless of the build engine. Yeah. And also remember, there is the build engine. That's one part, and then also there are different runtimes. Like Luca was talking more about the runtime, and again, the options and things might slightly change between different runtimes.
So thank you, Alvaro. This totally makes sense. So is there any other question from the viewers?
This means probably everything was quite clear. Let's wait a bit. I can wait a few
yeah, well, minutes. I mean, the presentation was great, I think, and you gave us very insightful hints. Between the presentation and the actual show on YouTube, there is like a small delay of 10 seconds. So let's wait a few seconds more if any question comes in. And yeah, let's. Okay, so it seems like there are no other questions to me. I'm not sure, Alvaro, Luca, if there is anything else that you want to add. I think your presentation was great. So thank you so much for, making a presentation is always, an effort. So thank you so much for doing such an insightful presentation and, present it to the community. Okay. We have a question, another one. So Mirko, let me show it. This is a good one. Mm-hmm. Does exist a good source of hardened images?
Good questions. I don't know if Luca knows one. I mentioned Bitnami. I know they work very hard on. I don't know if they are especially focusing hardened, but they are focused on reducing image size, performing a scan, and keeping track of the vulnerabilities and update often. So we could kind of consider them hardened. I also know, for example, many companies use Red Hat universal base images or derivatives, which are also very focused on security, especially for Red Hat environments. So I could mention those two. I don't know, Luca, you.
Well, maybe let me do a shameless plug here. Mm-hmm. So at SIGAP, we actually have a product called Certified Container Images, which is exactly what Mirko asked. Mm-hmm. Basically, these are patched upstream images. So these are upstream images that we scan and secure. So that definitely answered the question of Mirko.
Right.
Luca, I'm not sure. Sorry, I had to say it.
Yeah,
Luca, I'm not sure if there is anything else you want to add here.
Yeah, I'm very interested in that, and about that. When in doubt, I like to stick with official images, as Alvaro has mentioned. For example, Red Hat is doing a great job, I think, at making sure that their own images are updated. And this, unfortunately, is not just a matter of hardening, as we've seen, but it's also a matter of keeping things up to date. So this is an ongoing task. Sadly, we can't.
Just let me one comment regarding this and the mutant tags. So you see the problems that can arise. It happened recently to us. Luca, I don't know if you are aware, but we were building many of our images based on a UBI-based image, and the tag the security department was using was like :1 because it was the first version, but they were releasing 1.1, 1.2, 1.3, but they kept the tag :1 pointing to the latest 1. something release. And the problem is that our Jenkins builders were using :1, and the image was cached. So even the tag :1 was mutant, it was pointing to new images, but our Docker builders were still using the old version from the cache and building images that were vulnerable. So that's kind of problem you can find with reusing tags like latest or :1 or whatever.
Alvaro, if you read that thread, I also mentioned at some point that maybe we could also stick the hash there, because you can actually specify the hash. When you know that you have an immutable tag, you can stick the hash as well, and so to even make sure that the registry wasn't tampered with after the image has been built.
Correct. In fact, that's one of the fixes for tag mutability using the digest instead of the tag. But at the same time, the tags obviously are quite useful for other things and easier to use than having a 256 bits hash, right? So probably, but it is something to take into consideration.
Awesome. So again, Alvaro, Luca, thank you so much for your presentation. Thank you so much for answering all the questions that we just got. I really hope, as Luca said, that once all this pandemic thing is done, we will have a chance to actually meet and enjoy some pizza, beer, or Coke, whatever, together. And it was a pleasure to have you at our community. As they mentioned, Sysdig is hiring, so if anyone's interested, just reach out. And so see you next time.
Thank you very much, and I hope you enjoyed, and thank you for this opportunity and all the audience. Thank you. Bye.
Bye-bye.